Shove a robot dog on a flight of stairs and it does something almost alive. It throws a leg out sideways, stumbles for a step, and catches itself. Kick a rigid table the same way and it just tips over and crashes to the floor. Both have 4 legs. So what does the robot know that the table does not? Balance comes down to one line. Draw the patch of ground between the robot's planted feet, its support area. Now drop a straight line down from its center of mass, its balance point. As long as that line lands inside the foot patch, it stays up. The instant that line falls outside the patch, it starts to topple. The table cannot move its feet, so once its line crosses the edge, it is already gone. To play that game, the robot has to feel it is falling before you could ever see it. Tucked in its body is a tiny chip called an IMU, an inner ear made of silicon. It feels tilt and acceleration about 1,000 times every second. So the moment a stair or a shove tips the body, the robot already knows the lean and how fast it is growing. Here is the real trick. The robot does not just react, it predicts. From that lean, it runs the fall forward in its head, a fraction of a second into the future, and works out where it is about to topple. Then it plants the next foot at exactly the right spot to catch that fall, the capture point. New foot down, a fresh patch of ground, and the balance line drops back safely inside. It resolves that little puzzle every single step. And that one idea handles everything. Stairs, ice, a slope, a hard kick, they are all the same problem. The balance line is heading out, so predict where and step to catch it. That is why a robot on legs can walk up a staircase a wheeled robot would be stuck at the bottom of. It is not gripping the stairs. It is constantly falling and constantly catching itself. Subscribe for a new teardown every day.